Hi friends, today we'll see nanotechnology, which is second part of our sixth unit. In sixth unit, there is two parts. First is NDT and second is nanotechnology. So nanotechnology is a science, engineering and technology conducted at the nanoscale, which is about 1 to 100 nanometer. First, we'll see what is nano. Nano means 1 billion or 10 raised to minus 9 meters. To get these real sense, we'll see some example. For example, the human hair having thickness roughly up to 80,000 nanometer. So one human hair having thickness 80,000 nanometer. So we are getting the idea. This hair is too much thin. Still, in nanoscale it is 80,000 nanometer. Second example, one carbon atom. The carbon atom having diameter 0.15 nanometer. And third example about RBC. RBC is red blood cell. Approximately is 7,000 nanometer wide. So we are getting just basic idea about how much it is thin. Next, we'll see the atom are very small and diameter of a single atom can be vary from zero point 0.1 to 0.5 nanometer depending upon the element. Means different element having different diameter. For example, hydrogen atom will having different diameter than sodium atom. Then some basic terminology in nanotechnology is quantum confinement. In quantum confinement, we'll get idea about the dimension. Means a bulk material or solid has three dimensions. That's we already know. So in this unit, if you heard about the bulk material, then bulk material means a normal material having an ordinary size. Just we'll see one diagram. In this diagram, we can see this bulk material. This bulk material means the material having a dimension of normal range. See it having dimension along x-axis, then this is along y-axis, and this is along z-axis, and it is in normal range. So we are saying it is as a bulk material. Now we'll see in nanoscale if only one name of three-dimensional nanostructure is in nanoscale, that is from 100 from 1 to 100 nanometer. The structure is known as quantum well. This is quantum well we'll see here, where along x direction it is in nanoscale, that is in between 1 to 100 nanometer, while along the y-axis and along z-axis it is in normal dimension, which is known as quantum well. Next, instead, if two sides are of nanoscale, that is in between 1 to 100 nanometer, the resulting structure is known as quantum wire. So see this quantum wire. In this quantum wire, along x axis, the dimensions are in nanoscale, while also along the y axis, it is in nanoscale, while along the z axis, the scale is ordinary. So only along x-axis and along y-axis it is in nanoscale. So it is known as quantum wire. Okay. Then third, a nanoparticle is often referred to as a quantum dot, as its all three dimensions are in nanoscale, that is in between 1 to 100 nanometer. You can see here along x-axis, along y-axis, and along z-axis, that is x, y, and z. Along all three axes it is in nanoscale, so it is known as quantum dots. Quantum dots. Next, we'll see the surface to volume ratio. For that purpose, we'll see as the size of material approaches to nanoscale, the percentage of atom at the surface of material becomes significant. Nanoparticles has very high surface area to volume ratio. Because when you are considering bulk material, that time interatomic distance is more. So sometimes we know this void. Due to that, this surface area to volume ratio is less. Just we'll take example of some atom, because mostly we are considering the dimension is spherical. So just see this diagram where these atom we have considered it having some surface area as well as volume. The surface area of these we can write as 4 pi r square, while volume is 4 by 3 pi r cube. If you take the ratio of surface area to the volume, we'll get it 3 by r, which is significant value in nanometer than the bulk material. Next, we'll see how it is significant. So, significance of nanoscale and change in properties of nanoparticles. Many properties of solid, such as optical, electrical, mechanical, etc., depend on its size as compared to its bulk form. Properties of material change when at the least one of the dimension of the material is reduced to nanoscale, mainly due to following reasons. Means, if any one dimension is nanoscale, as we are seeing in quantum confinement, that time the property of nanomaterial changes from bulk material due to the following reasons. These reasons are: first is, upon reaching a quantum confinement at nanoscale, energy level of nanoparticles become discrete. Discrete means it gets separate. These increases or widen of the band gap, and the band gap energy increases. These results into change in the property of material. In short, we can say from bulk material to nanomaterial, when we convert these bulk material into nanomaterial, that time its energy changes. And the band gap is increases. Due to that, the properties of nanomaterials are changes from bulk material. Second, nanoparticles has relatively large surface area when compared to its bulk form. This makes the nanoparticles more chemically reactive compared to bulk form, and thus modifies its property. So, as surface area increases, material surface area increases, so the chemical reactions or chemical response is vary, and due to that, the nanomaterials are different than bulk materials. Third reason, the physical properties of the material, such as electrical, are characterized by the mean free path. You know what is mean free path? It is the path of electron collision due to atom or ions. Inside the element, if there is a collision between atoms and ion, that time that path of electron, that path is mean free path. These mean free path change the nanoscale, that is the properties of nanomaterials. And last is the bulk properties of material such as hardness changes at nanoscale. Nanoparticles are much harder and tougher as compared to their bulk form.